Electricity plays a major role in this technological society. In 2014, the Netherlands consumed 112 gigawatts of electricity. With this clear tendency, it's obvious that energy sources need to be reconsidered. Utrecht University and UMC Utrecht will install 6,500 solar panels in Utrecht Science Park the Eindhoven, giving the campus the largest surface of solar panels in Utrecht and ranking the area among the top 10 in the Netherlands. Annually, the 6,500 panels will generate around 1.5 million kilowatts-hour of electricity, as much electricity as the annual consumption of 430 households.
So we have arrived at the University Utrecht campus the Eindhoven, and now we're gonna have our interview with the expert Wilfried van Sark about the solar panel project of the University Utrecht. But before that, we're gonna shortly explain the basic principle of a solar panel.
So let's take a look at the basic situation here. The sun emits light particles that hit the solar panel. If we zoom in, we can look at this in more detail. Solar panels consists of a semiconductor material which has a special feature. Electrons can only move in one direction. In this case, from the bottom to the top layer. If now a light particle with enough energy hits the panel, it can transfer its energy to the electron, and the electron can move to the upper layer. Its free spot is taken by another electron, and so a current, which can for example light a bulb, is generated. This is the basic idea of how a solar panel works.
Well, my name is Wilfried van Sark. I'm Associate Professor at the Geoscience faculty since about 3 years now. About the project, there will be 6,500 PV panels on the roofs of the university campus buildings, about 4,000 on the Utrecht University buildings, and 2,500 on the hospital. This will amount to about 1.7 or 1.8 megawatts of power, which can be reached only when it's fully sunny, and for the rest of the year will be smaller. It will be probably 3-4% of the total electricity consumption of the campus. They want to become more sustainable in many ways, in their processes, in their research. Actually, the research was ahead in that sense. The materials research, but also system research, and how to get more sustainability into the world. And we at the university thought, well, we should start it as well here on a small scale at the campus itself. So they're part of the Sustainable Campus Initiatives and so on. And although PV is only 3-4% of the total annual electricity usage, it still is a nice signal. Essentially, it's a plate of silicon material, semiconductor material, which absorbs the photons in the light. It's getting electrons and holes apart in the device and separates them in the device so that you can have externally some power current running actually. I think the future is local. So 50 to 70% of people will be living in cities in the coming years. So locally generated power is then the solution. In the Netherlands, which is a showcase country, this is going to happen in, I think, very soonish, in a couple of 20 years or so. Worldwide, I think PV is a major source of electricity by the end of the century for sure, and also, well, part of that also in the middle. That's really necessary for a sustainable future.
In 2014, the photovoltaics contribution to the Netherlands' electricity demand amounted to roughly 1% of the total, matching the worldwide average. Over the same year, 177 gigawatts of photovoltaic systems were installed all over the world. At the end of 2014, over 20 countries had surpassed the 1 gigawatt mark of cumulative capacity in photovoltaic systems.